Okay, good afternoon. Good afternoon, everyone. Welcome back again to the Design on Cloud Pavilion, which has been sponsored by Google Cloud and Microsoft. Thank you all for being here today. We've got just a few more speakers, but still some great speakers coming up. I'd like to go ahead and bring onto the stage Chico Wu, who is with FootPrintKu. So let's please give him a warm welcome.
Thank you, Derek. So DAC is traditionally, more predominantly, a show for the semiconductors. But as we're seeing the hardware DNA evolve into more and more miniaturization, the lines between the system level and the chip level are starting to blur. But in between that is the board level, which is where we play. Our space is on that board level. So today, I'll be talking about automation, libraries, and digitization. Now, whenever I think about automation, I start to wonder, how does this affect me, our work, our future, our careers? Because automation is increasingly becoming a larger and larger part of my life. So, why don't we look at this one question first as we begin? What's our perception? Does less automation and less robots increase our job opportunities? And in that same regard, does more automation and more robots reduce or eliminate some of that job opportunities? My name is Chico Wu, and I'm in the hardware design industry like most of us here, and we're always looking to solve challenges in our field. This is the library design field for us. So back to that question about automation. And to help us answer this, let's look at a very recent example. So we all know that automation has long been used in the industrial and automotive manufacturing sector. But did you know that over the past few years, 60,000 robots were installed here in the US, and during that same period, employment increased by over 200,000 people. And this just didn't occur here at home. This happened in Europe, specifically in Germany, where they installed 90,000 robots. And employment increased by 90,000 people. So we're seeing a minimum of a 1-to-1 ratio. For every robot installed in the automotive sector, employment has gone up. And as automation continues to develop, it's getting faster, smarter, and it's always learning, which gives us that AI technology. Now, some of the advantages and benefits, usages we're seeing today in AI are our intelligent assistants and other smart hardware. And tomorrow we'll be seeing self-driving vehicles, cars, trucks, and who else knows what other forms of transportation. But why is it that we don't see more AI used in our industry of hardware development? You see, when it comes to libraries, we're still using a very tedious and a manual process of creating our board level libraries. This is essentially component data entry. And the reason why it's very tedious is because all the spec sheets that we receive are in PDFs. But you can't take a PDF to a manufacturer and say, build this. You can't use a PDF in actual design. It's only a reference document. What if there's a better way? Well, we'll get to that. But first, some of the issues that we see with PDF and library design starts from the creation part. The number one errors are caused by typos. One incorrect pin number, one incorrect pin name, and we're spending thousands of dollars respinning our design. Or, how about resource challenges? For example, very slow on-the-job training, learning new rule sets. Or how do we ensure continuity of our resources as engineers change jobs or they exit the industry altogether, perhaps through retirement? And if we get to the very fundamentals of creating and building a part, it's very time-consuming. We're spending time building each schematic symbol one at a time, each PCB footprint one at a time, and each 3D CAD model one at a time. And after you've created this whole library, managing it is a whole different ballgame. Now I'm talking about inconsistency when it comes to centralization. Within the same companies, some engineers use different naming conventions. Within the same companies, some engineers are using different tool sets, inconsistency of data format for the same task. And as manufacturing technology continues to evolve, we're not going back and updating those existing library parts that we've already created. For example, components these days, equipment allows us to place parts closer and closer together. But we're not going back to update our boundaries on our library parts to enable that density advantage of future designs. Or how about something as important as search? Most of us are still searching by a naming convention. What if we could search our libraries with specific properties? What if we could search for specific via characteristics in our libraries? So is there technology to help us solve some of these problems? And the answer is yes. So at FootPrintKu, we were able to come up with spec sheet digitization, which is essentially using a digitization robot to build libraries for the board level. This is like having an engineer with their own digitization robot assistant, so they can focus on more important tasks. And to help us get to this technology that we created, we had to establish levels of digitization, starting with no digitization, which is a very manual process. Now this is fully people-powered, but we have challenges with limited capacity and limited throughput. Now we can compare this to the previous drafters using rulers and tape, drafting boards, and these drafters were able to level up with computers and EDA software to the semi-digitization level. Now this is the partially assisted, giving our teams more tools to improve and increase their productivity. Can you imagine not running DRC utilities today or running a DFM check before you tape out? This is where we are today. And this is a process that we've been using for the last 15 to 20 years. But at FootPrintKu, we think there's a next level, which is smart digitization. This is that fully automated process, yet simplified way of connecting and creating library parts. It gives us that productivity boost, but it also allows our engineers to level up and have that net gain of employment. So what we're seeing is that automation optimizes that repetitive manual process. It's not eliminating entire occupations. And with automation, it elevates that productivity. It also creates affordability by driving down costs. And one of the byproducts of that is growth. Now, there's a lot of different forms of growth, and I'm sure most of us here has seen the EDA industry go through that tremendous amount of growth. But when it comes to libraries, we're still stuck in processes that are 15 to 20 years ago. What is that next step? Perhaps this. So here's a list of some of the leaders in our industry. They're always creating new tools, very advanced, and paving the way for the rest of us. And each of these tools, they output a Gerber format for board manufacturing or a step format for mechanical. which is then imported into every manufacturer's CAM tool. This is essentially that industry standard format for manufacturing. But if we go up the design chain to the component level, whether it's a semiconductor manufacturer, a connector manufacturer, or any other components, as a designer, the data that we're receiving comes in the form of a PDF. And if we don't use the same tools that these component suppliers are using, we are redrawing every single component. We're extracting that data out of that PDF visually into our specific ECAD tool or MCAD tool, because there's a disconnect. We can't bring in that PDF into our EDA tool. What if there was a way to connect the component suppliers to the board designers, or the mechanical designers, or the electrical designers, streamlining that process so that engineers can go straight from component selection into placement, into their hardware design, into schematic design, without redrawing information out of that PDF. This is the industry future that we are looking to establish. So as I conclude, I'd like us to think about, if we have a standard for manufacturing output data, why is it that we do not have a standard for our component libraries that can be imported into every single one of the leading EDA tools? So I've talked about automation and robots. What I'd like to do now is just a quick introduction of the robot that drives the automation behind FootPrintKu. It's a short clip that's coming up right after this. If you'd like to learn more about how we're helping companies optimize their process and reduce their design cycle by half, please visit us at the FootPrintKu booth 1249, and I can share more information with you about that.
See these guys? They're about to go to market, and they got here fast. Thanks to me and the secret art of FootPrintKu, we kicked their old way of building an EDA library right in the pants. You know how manually building a library can be painful and slow, and how mistakes happen all the time? Let me and my robot army automate the process so you focus on innovating instead of tedious manual tasks. We're accurate, efficient, and always learning. You'll have those schematic symbols, PCB footprints, and 3D models in a day or two instead of a week. And your new EDA library lives in the cloud, so it's always accessible. Yeah, it's pretty cool, right guys? Do more, deliver more. FootPrintKu.
All right. Any questions? Well, thank you everyone for your time.